Welcome back, everybody. In this video, we'll be doing examples 1.3.4. It's going to be a way of illustrating what I said before, that all spans are subspaces and all subspaces are spans. All right, so we'll see how to write these subspaces, this one and this one, as a span of certain elements. All right, so example 1.3.4, show that the following subset are subspaces of the given vector space and write them as a span. All right, so here W is the solution set of a linear system. That linear system is homogeneous. And so that is enough because we proved it in theorem 2.2.2. It is a subspace of E3 because I have three variables. So I'm going to find generators for this. I'm going to solve the system. So I have 2 minus 1. Don't forget to add z. Z doesn't appear here, but it was part of the definition. And so 2 minus 1, 1. I'm going to reduce. I'm going to get 1 minus 1/2, 0. I have two free variables, s and t. And so I'm getting that x is 1/2 s plus 0t. Y is s, z is t. And so I'm getting x, y, z equals 1/2 1 0 s plus t times 0 0 1 for s and t in R. All right, so I have written anything in W as a linear combination of these two vectors, and so W is the span of 1/2 1 0 0 0 1. All right, so this W is a subspace because it's a solution set of a homogeneous linear system, and we managed to write it as a span by solving the system. All right, next example, I have a set of matrices A, B, B, A, where A, B is in R. All right, if you're not in Rn, you can't really use homogeneous linear systems because the solutions will always be in Rn. So what we have to do here is, I'm going to be a bit sneaky. I'm not sure if I'm playing a trick on myself by doing it, but I'm going to take A, B, B, A, and I'm going to write it as A0, 0A plus 0b, b0. So I have, in some sense, two parameters, a and b. I'm going to split the part that contains a and the part that contains b, and that's going to give me a times 1 0 0 1 plus b times 0 1 1 0 for a, b in R. Well, that means I've written it as a span. All right, so we've done the second part, write them as a span, but we haven't done the first, right? If I really wanted to do the first, I'd have to prove the three properties, which I don't feel like doing. And so what I'll do is I won't cheat because technically we've proven it, but I'm going to use this theorem here that says that if I could write something as a span, then it is a subspace. And so instead of proving the three properties, all I have to do here is once I've written it as a span, by the theorem that we just proved, I think it's 1.3.1, sorry, 1.3.1, by theorem 1.3.1, W is a subspace of whatever vector space you're working on, so of M22. All right. So at this point, we have two shortcuts to proving something's a subspace. We can use that as the solution set of a homogeneous system. So for things in Rn that are given like this, that's the quickest way. And then if we could write it as a span, then we have this new theorem, 1.3.1, that tells us that any span is a subspace. So these are two shortcuts. Using them, you can avoid proving the three conditions, the three properties. But if I ask you to prove the three properties, then you cannot use these shortcuts. All right, so that's it for the video. We'll do more soon.